Okay, welcome everyone. It's Webinar Wednesday. My name is Andre Mueller, and I'll be showing you a little bit of Studio 3 and a specific macro called Orient 3. It's only a short demonstration, but basically what this macro allows you to do is to view structures down your hull, any joint sets that you've got, or any bedding, or any faults that you might have logged in a drill hole. Well, then you're able to just display those down a drill hole. And I think it's quite an important macro to use if you're exploration, also underground environments. If you watch on, and I'll show you how to use it. Firstly, just to show you what the macro looks like. So basically we have Studio 3. I think everyone's pretty familiar with Studio 3. If I come to my macros, and it's called Orient 3, and I go Edit, and I view the macro via either Notepad or TextPad, whatever you prefer. Now, what we're going to be doing is we're going to be pulling in data points from a drill hole file, and that drill hole file is actually called 2dat, and it's just used as a substitution variable in our macro. Now, when we create a 3D string of the structure down the drill hole, we'll also create a string and also a triangle file. So it creates a 3D string and triangle at the true azimuth and dip of each downhole depth data point with the structure measured relative to the hole. So if you've got an orientated core, if you've got a hole that's got a bit of swing on it, and it deviates, well then it will take into consideration that. So in the input file, we need a X, Y and Z coordinate, also an A naught, a B naught, a relative ASI and a relative dip. And basically the information about this is given in the top header of this macros. Basically where A naught and B naught are your ASI and your dip looking down the drill hole, and the relative ASI and the relative dip azimuth is the dip relative to the sample. And then the output files are basically the string file, which is called 2st, and then a wireframe file also, which is called 2tr and 2pt. And they're listed all in these substitution variables here. If we wanted to input the data straight from this macro, we can also do it through this part of the macro, but we're not going to do that today. And then further down the macro, you'll see it actually starts to get quite complex, and I'm not going to go through the mathematics of it. As you can see, it gets quite complex in the extra statement that it runs. And then the final file that it actually gives out is a string file and also a triangles file, which is it uses the function cogtry to create those. So I'll just close this up. So just to view the drill hole data before we go and basically put it into the macro. So I load up the drill hole file. This is the drill hole file, and you have the same in your database. You'll have a number of drill hole files, and what you'll need to do is you'll more than likely have to use either or both the pick-rec statement, which is a batch process, or extra statement, and you need to flag out all the points down your drill holes which have a weave measured structure. So to give you an example, I've already done this one. And basically all it is, it's just picking up your drill hole and it's just pulling out all your structures that you've logged in your drill hole. It would be orientated core, of course, and you'll be getting your, I believe your alpha and beta angles. And for each of those points down your drill hole, you'll have a relative dip and a relative ASI. And at those points where you've taken that measurement down the drill hole, there'll be a point down the drill hole. Now, in your drill hole file also, you'll have, or in your drill hole file that you've used pick rec and an extra statement to get this data out, you also have basically your bearing or your ASI and your dip, and then it will have a from to. Notice there's no distance between the from and to because it's a point, and it's got 0 length. So just be aware of that when you filter your drill hole file to get out your structures or your measurements out of your drill hole file. So just make sure that they are similar to what I'm showing here. So also with the relative dip and the ASI, you have the structure name, and the structure name here, it's foliation. You can see there's some bedding and there's a fault all the way down your hole, and this will display the structures down the hole, so I can basically use the legend to display any of these structures, which I'll show you in a minute. So if I close this back up now, and the file's called 2dat, and that's been hardwired into this macro, but you can change it to whatever your data that you filter out of your drill hole file will be called. As you can see, there's no other files in my drill hole. I'll just get rid of the just to show you where that drill hole was. I'll just delete that out. And actually, I can load this up. I can load this up and show you the exact points down the drill hole. So I loaded up the 2dat file, and you can see all the little points down the drill hole where these data points are. So for each one of these data points, there will be a measurement. And what I'm hoping to get out of it is a small little string file with a triangle on it, and with the triangle being a little wireframe, so you can see the orientation of your structure. So now if I go and run my macro, so here's my macro, and I right click on it and I go edit, and I run my macro. It's called macro 1. The first time you run it, it always comes up and asks for a file, but the files are created, and you'll see that it creates a points file, a string file, and also a wireframe triangles file. And if I want to view those, I can just drag and drop those into the VR window and they'll load up. And you can see all my little triangles with the orientations, which way they're pointing. Okay. So now what I'm going to do, because in our in the points file, in the actual points file that we had, you can see that the structure has a name. Now all I'm going to do is I'm going to colour those structures based, or these triangles based on the structure. I'm just going to come into the VR window and select wireframes, and I'm going to click on the 2TR and the 2PT. And then I'm going to select structure. And I'm going to use the default legend that it creates. So it's just going to look into that object, into that column, and it's going to create your legend. So basically bedding, contact, fault, foliation, and then I'm going to hit apply. And now you can see that some of my triangles have bedding on it, some of them are foliation. zoom out a little bit. You can see that there's a fault in there as well. Now, if I just move that to the side. If I come back to my projects file, I can also load up the strings associated with this as well. Now, the strings are a different colour, so of course we need to come over to the Sheets window, and I need to colour strings based on the structure as well. So if I double click on string properties, select lines, and then select structure as well, hit the default, hit apply, hit OK. And now you can see each one of these strings has the same colour as the triangle because it's based off this legend. Okay, so from that also, what we can do, we can either, if we've got a fault running through here and we were able to get the angles on that fault, I can either use plane by 3 points and get into the plane of this triangle and then draw a fault. So if I go plane by 3 points, 1, 2, 3, well then my plane is sitting directly on that surface of that triangle. If I orientate it perpendicular to what that triangle is by using this button here, and then I zoom back out, I'm sitting directly on that face. Oh, I might have not done it. Let's just have a look, make sure that did work. Plane by 3 points again. Just make sure I don't have another. Oh, I've got a default section up, that's why it's not moving to that face. So I just need to delete out that default section. So now let's try that again. So plane by 3 points. Now go perpendicular to it. Now, if I want to draw on that fault, or draw a surface on that fault, I can just go create new string, which creates a new string file down here. And then all I'm going to do is go new string, and I'm just going to draw a random fault surface, which is going to cover the area. I'm going to go CLO. Now, if I want to make it the same colour as the fault colour, I can use EAT and just colour the string. I know it was yellow. You shouldn't really use yellow because that's a highlighting colour, but for this demonstration I will. And then what I'm going to do is create a fault surface. So I'm going to create a new, basically a new wireframe for the fault surface. So it's create new wireframe. So it's CNW, create new wireframe. And then I'm going to close that surface using ELI end link, or it just basically fills in a closed string. So ELI, right click, go done. And then when I rotate this around now, you'll see that that wireframe triangle is sitting, or basically this wireframe is sitting on that surface. So from there you can start mapping out all your faults. You can also do the same with bedding if you want to show a bedding. Exactly the same. So if this is bedding here, we could do exactly the same. I could go plane by 3 points again. So 3, 1, 2, 3, and do exactly the same. Look perpendicular to it. And what I'll do is go new string again. CLO. EAT, I'm going to change the colour to blue this time. It might be a bit cluttered at the moment, but you'll see that now when I put in the surface here, actually I'll just change the background colour because the background colour might be so what I'll do is create a new wireframe surface there, go ELI. So you can see you can start mapping out these structures based on your drill hole and the orientation of those triangles down the drill hole. And that's sitting exactly on that surface that you can see just here. So we can also, instead of drawing wireframe surfaces, we can also do planes based on these wireframe triangles. Now to do that, we can basically, I'm just going to turn off the triangles and I'm going to zoom back out and I'm going to highlight. I'm going to highlight all the strings down that drill hole by just highlighting it, just drawing a box around it and highlighting all those strings. Then I'm going to come up to Design, String Tools, Convert Strings to Planes. And it creates one vertically because that's down the drill hole. But if I delete that out, yes, and I zoom right in, you'll see that each of my strings have got a plane along it. Now that's got a dip in a dip direction with that plane. They're the planes over on this left-hand side here. Now I can change the size of these planes and I can colour them based on whatever structure is associated with it. So if I want to colour the planes, all I do is come into it. I can select structure, I can select the default, and then I can hit apply. So I'm not sure if I like that blue background, I might change that to black. So now you can see all the structures down the drill hole. They look quite small, so if you want to make bedding larger, what we can do is we can change that in the file. And we can change that via an extra statement, which I think is important to do if you've got faults and you want to show the fault to be larger in size, so you can start linking them up between drill holes. Well, then I think that's important that gets done. So to do that, we've got this new file and it's called New Planes, and I'm just going to save this. New Planes. And we can make the faults larger, which will only be one surface, or we can make the blue ones or the bedding larger in size for the planes. And to do that, I'll just come down and I'll just run an extra statement. So extra, just type it in down the bottom here. And I pull up my file, which is the one I just saved, which is New Planes. And I'll give it an out name, it'll be New Planes Bedding, but I could do fault if I wanted to. I can go OK. And then all you have to say is if structure equals, and then you have to open up your brackets, bedding, because we know that bedding was one of the structures, then close brackets, then the V size and the H size, this here, is the size of the plane around the outside of the string. Now all I've done is I've said V size equals 50 if that's the case. So if the structure equals bedding, then the V size equals 50. And you can say a number of these all the way down. You can do bedding, you can do foliation, you can do your fold, you can do your contact, you can do your bedding. So whatever you want to do, you can just copy these down and just change what it's looking for. Make sure you always hit test to make sure it comes out okay, and then hit execute. Then if that's just created a new file now, so if I go into the projects file and go and open it up, what we should see is instead of this plane here, we'll see a lot larger plane. And there they are, those 3 planes. And you can colour those separately. You can colour your planes file based on this legend as well. And you can imagine if you had a number of drill holes, you would do this. You'd be able to do this all in one. I'm just doing it on one drill hole because it makes it very simple, so people can see the process that you need to go through. So after creating your planes, you can also use the StereoNet to view all your data, and you might find that you've got certain areas where you want to segregate certain drill holes because you might find there's a different foliation or different orientation that you want to see, and you want to plot it maybe on a StereoNet or something like that. So just remember that in Studio, if I go to Applications, Charting, and then I go StereoNet, it comes up with a StereoNet plotter, and we've got the files ready loaded, so all I have to go is go and select it up here, so new planes, and then it picks up the S-dip and the dip direction, and that comes directly out of this file. I'll open that up in a minute just so you can see what's in this file, but it will automatically pick up the S-dip and also the dip direction. So it's basically the dip and the dip direction of those structures, of those planes that we made. So if I hit apply, and you can see it comes up on our StereoNet plotter, and you can also do colour maps of it and show the congregations of those sets. If I go and open that up now, so this is the planes in the VR window. These are all these planes down here, which I'm viewing just here. And when we use those strings to create those planes, it gives us an automatic dip and a dip direction in this. This was the H size and the V size that I used, that I set to a default of 50 in the extra statement. So you can change these based on whatever the structure type is when you run that extra statement. So finally, look, if you want to know more information about how to use Orient 3, you can just email support, and what I'll do is I'll give you the Orient 3 macros that you can use, and if you need additional help, well then just email support and we'll see how we can help you out. That basically concludes today's webinar. I hope you learned something from it, and I'll talk to you all next time. Thank you.